the first step is to choose a bridge. Now, obviously you're restricted to trusses, but as you can see here, there's a huge variety of trusses out there, which you are more than welcome to choose from. However, I would strongly recommend trying to keep this simple, and I'll explain why. You can see here we've got a nice simple how truss here. Why this is a recommended design is the amount of beams it has is very limited. So we have a vertical beam here, and that actually is the same dimension as my horizontal beam. So I can use the same jig to measure that. And the only other one is this one here, the diagonal. So I only need 2 jigs. So these jigs are what we need to design three-dimensionally and 3D print so that our model has a lot of accuracy and precision. You can see that they've got these little notches in here. These notches are going to help us cut out our halving joints, and the halving joints are going to make this a much more sturdy structure so that it's got a physical bond at the joint rather than just solely relying on the glue. Now, like I said, that's that how truss I showed you only requires 2 jigs. If you want to get a little bit more fancy, you've got this one here is a Baltimore, and it's not too much more effort, but you can see that it's now got an additional diagonal and additional vertical, so it requires 4 jigs to do. I would say the upper limit you would want to go if you did have very good 3D modeling skills would be a Camelback K truss. This one now requires 8 jigs, so it's essentially 4 times as much work as someone doing a how in terms of jig production and cutting out your beams. Then you can of course go ridiculous if you really wanted to. In other words, if you were not very smart, this is a bowstring K truss. You can see this one's incomplete because the student couldn't finish it in time. Required 23 jigs. Would not recommend that. Okay, so for this video series, I'm going to keep it nice and simple and do a how truss, but for all intents and purposes, the skills I'm going to present to you can be translated to any number of trusses or designs. So this is my simple how trussing. You can see it's in 6 sections, and for simplicity, what I want to do, so that I can get some get these diagonal beams on 45-degree angles, I'm going to make sure that these horizontal and vertical distances are the same. So the first thing I do before I start moving over to Onshape is figuring out what is that length they're going to be, the length of my individual members. Now, I know that the entire length has to cross a span of 18 meters. Now, that by our scale of 1 to 30 will equate to 600 millimeters long. Now, unfortunately, that's the actual gap, 600 millimeters long. So we actually need to make it a little bit longer. Now we're going to have abutments on each end, and they're going to be made up of the thickness of 1 member. So it's going to be 600 plus 6.5 plus 6.5, which will give us 613 millimeters. Now, 6.13 is not divisible by 6. Well, it is, but obviously it's going to give me a nasty little number there. So I'm going to choose the next the next highest number that is actually divisible by 6, which is 618 millimeters. So now I'm going to have beam lengths of 103, and so these ones here will be 103 wide. That's my key number for this design that I've done. You don't have to have 6 sections. You might want to have 4 or 8, whatever it is you choose. You just need to come up with whatever that length is going to be based on this long span. From that, you're now ready to move on to Onshape and doing it in there.